Hello, this is Catalytics and welcome to today's session. In today's brief video, we are going to look at how we can use the SPSS platform to be able to run multinomial logistic regression analysis. In our previous video here on this channel, we spoke intensively about how we can use the Stata platform to be able to run the multinomial logistic regression analysis. So this video is just to give you a work around that same approach, but using a different statistical software, i.e. SPSS. And so without wasting much time, we want to start by going to Analyze. And then we click on Regression. Then we come to Multinomial Logistic Regression. Then we click on it. Then we had already run this earlier. That is why they are loaded there already. Generally, we want to select marital status as our dependent variable. And you can select the dependent variable that you want, depending on the type of analysis you want to run. But then the fact still remains that for a dependent variable, it needs to have more than two categories. And it should be a categorical variable. Marital status has more than two categories, and it's a categorical variable. That is why we have used that. Then generally by default, it selects the last category as the reference category. But you can work around it and change the reference for the category. It can either be the first or you customize it, but we'll select the first one. And this one, you can leave it as ascending or descending. We'll leave it at the default setting ascending. Then we'll go to our predictor variables. We need sex as a factor, occupation as another factor, and educational status, and then age will be a covariate. Now over here we have model. So when we select model, we have opportunity to select whether it will be a main effect, full, factorial, or custom, or stepwise. We'll select or we'll leave it as the default setting, the main effects. Then the statistics bit, we have several statistics that we can allow to be displayed. So we have the model statistics, which is the pseudo R squared, the step summary, model fitting information criteria, which will present the archaic and then the Bayesian information criteria. Then we have the cell probabilities, classification table, goodness of fit, monotoxicity measures. And then when it comes to the parameters, we have the estimate, the likelihood ratio test, that's the asymptotic correlation, the asymptotic covariances, and then a confidence interval. We can actually change the confidence interval to any value we want, 99, 90, 95, and so many other. And then the definition of the subpopulation, we use that. So we will continue. And then the criteria, we leave the criteria just the way it is for the default setting. And for the options and save, as well as the bootstrap, we'll discuss that in another video. So we then click on one. Okay. Then wait for the outcome window to give us an outcome. So here we have the nominal regression. Gives us the warning and then the case processing summary. Then down a little, or in a case processing summary, gives us the number of valid inputs as well as the missing inputs and the total. Then we have the model fitting information. So the model fitting information gives us the model fitting criteria. It gives us the -2 log likelihood values, as well as the archaic information and Bayesian information criteria. And the lower the value, the better the model. So when you run two different models and you want to compare which one is better, for which reason you want to use those predictor variables in predicting the outcome, then you settle on the one with the less criteria or from a fitting criteria. And the significant level is highly significant. Then we have the goodness of each test, the chi-square value and the significant level, as well as the pseudo R square, which somewhat gives us information about the percentage by which the predictor variables are able to explain a target variable. And then we have the likelihood test, which are all significant, but for educational status. Now, the parameter estimates, these values are what we'll be interested in, the significant levels and the confidence interval. And if you watch the Stata multinomial regression analysis video, you come to see that this is the relative risk ratio, and the interpretation of that in respect to the type of analysis we are doing here, multinomial regression analysis, was done in that video. So you want to take advantage of that video so that you can be able to learn how you can do the interpretation of your results that is presented here. Now, if you like content such as this, we encourage you to turn on the push notification bell after you are subscribed, so that you are always notified whenever a new video like this is produced or shared. Equally, if you're a returning subscriber, we encourage you to like, so the algorithm recommends this video to as many people as can to also learn from. Additionally, in the description of this video, we have our WhatsApp channel, which gives a breakdown of all the videos that are presented on the YouTube channel. And so you can be able to follow through stepwise to be able to learn and equip yourself on how you can be able to become effective in doing statistical analysis. So until we meet again on our next one, this is Schedulytics, and it's a bye.